Yes. Yeah. Still about to do. At all. So, in case you forgot, write this 3. Differentiate 3 gives you 0. Differentiate 3 gives you 0. 4 sine cube, right? You write it, you see as 4 sine x power 3. Wow, so loud. Okay, so then you see something power 3. Correct? Inside sine x. Or sine x. Outer layer is what? Differentiate outer layer, you get 8. Correct. So 4 times 3 power 2, like that. Differentiate inner layer, sine is cosine, correct? So it's cosine x. Or, okay? So you get 12 cosine x multiplied by sine square x easily. Okay? Yes. One part? One part two. Okay, give me a second. I get to that very soon, okay? Then after that, what do I do? So you change sine square as 1 minus cosine square. Okay, then after that, you have everything in terms of cosine. This is 12 cos x, 1 minus cosine square x. That gives you 12 cos x minus 12 cosine cube x, which is your part 1. Okay, all? Can all? After that, how do you do part 2, right? Okay, so you remember for calculus, right, we always do it in gradient mode. Okay, so yeah, you're going to say something. Evaluate. Cosine pi over 6 is a special angle, so in case you want to cosine 30 degrees, right? So then it is square root 3 over 2. Square root 3 over 2. Okay, okay, some helpful tips. Cosine pi over 6 is square root 3 over 2. For those who need. Okay, cosine pi over 6 is square root 3 over 2. Okay? Can I? Slowly, I help you with question 2. So we know that equation of tangent, right? Equation of tangent is y minus y1. Gradient x minus x1. Don't have to listen to me if you want to try yourself. No worries, no hard feelings. X1 by right is pi over 6. What is y1? Then you start lah. Okay, so y equals to 3 plus 4 sine pi over 6 to the power of 3. Sine pi over 6 is half. So this is half power 3. Half power 3 is 1 over 8. So you have 3 and 4 over 8, which is the same as 3 and half. Okay, Ethan? Are you okay? Okay, so then after that, you know that this is 3 and a half. This is pi over 6. Then you sub dy dx. Dy dx would be 12 cosine. Remember, you sub in x1 pi over 6. Minus 12 cosine cube pi over 6. Or what does that give you? 12 of square root 3 over 2. 12 of square root 3 over 2 power 3. Okay, now because they want exact, so we got to leave it in exact form. Okay, cancel this. I think you have 6. Is it 6? No, don't say 7. Okay, so 6 square root 3 minus 12. 12 times 3 over 4 is 36 over 4. 36 over 4 is 9. It's 9. 9 over 2. 9 square root 3 over 2. I hope I'm correct. Okay, can I think I show the rest for you. Yeah, over here. Is 9 over 2, so 25. So we get okay, and a half. 3 and 3 power half. The y value is 3 minus. Is there something wrong? Let me check. Okay, so 3 minus 4 of half power 2. Okay. Oh my god. Okay. Is it easier to change the question or the answer? Okay. The answer. Okay, I listen to you. So then this is 3 plus. So 3 plus 4 will be 3 and that will be 7 over 2. Okay. Then this one will be 7 over 2. Am I correct? Then this one will be 7 over 2. Yes, very good. Timothy can be teacher. Huh? Right. Well, they're all human. It's easy to solve question. It's difficult to set question. So this is question 1. Question 2, I think is a proof, so there's nothing to show you. Question 2 is a proof. Question 3, part 1, also a show. Question 3, part 2. You have to try don't push yourself so hard after your quiz. Okay, so now I'm going to go through question 2. Question 2. Okay, so in a while's time, then I'll go through question 3. Okay, so I hope you all are okay. Slowly. Okay. Question 2, right? Basically, left-hand side, right-hand side. Okay, if you notice how the 1 disappears, right? You basically need to eliminate the 1. And notice how you start with an x and you need to end with a half x. The x needs to end with a half x. Right? That means it's a half angle formula or double angle formula involved. Remember I told you if you got double angle for cosine and you got 1, you need to Q off the 1. Okay, so what you do, very simple. For the numerator, you substitute 1 plus, write this as 2 cosine square x over 2 minus 1. This will take over the cosine x. This will take over the cosine. That will get rid of 1. Okay, denominator, you use the other formula. You use 1 minus 2 sine square x over 2. This will get rid of another 1. This is going to end you up with none other than 2 cos square x over 2. The denominator is 2 sine square x over 2. Cancel off 2 from top and bottom, and you are left with none other than cotangent square. Easy game. Okay, I saw most of you can do it very quickly. Now, so of course comes the difficulty in the left-hand side. Yeah, left-hand side I think is a meant to be a killer question now. Yeah, so if you the idea is that when you have function A equals to function B, then the derivative of A is equals to the derivative of B. But the converse is not true. Just take note, the converse is not true. Okay, the converse is not true. If two functions are equal, it does not mean that the integral is equal. Okay, never mind. You haven't learned integral yet, so we will talk about it another time. Yeah, we haven't learned yet. So if two functions are equal, does not mean that we integrate them, it will be equal answer. Because that's an arbitrary constant. Okay, so now if I differentiate, the idea is that if I differentiate 1 plus cosine x, and I believe most of you got it. I'm just taking a small sample size, about 10. I walk around, I think most of you got this, minus 2 sine x. I shall not go through lah, okay? The right-hand side, when you differentiate, what do you get? Yes, when we differentiate, okay, so I think some of you have this issue, not issue, a challenge lah. How do I differentiate cotangent square? So guys, differentiating cotangent, you write it this way, half x to the power of 2. Now, this is layer number 1. This is layer number 2, pink color. Let me use another color. What color can I use? Do they all look the same? Gray color. Alamak, now it looks so disgusting. Okay, cannot see it. No other color to use. What about red? Can you see? Got 3 layers. Can see not? Trigo, when you differentiate, you must be very careful. The layers are really scary. Okay? So differentiate first layer, something power 1. Differentiate second layer. What is differentiate cotangent is minus cosecant square. Differentiate half x is half. Which is why your final answer 2 and half cancel off. You get minus cotangent half x cosecant square half x. Now, ladies and gentlemen, you look at your left and your right. Look at the left and the right. What can you do? You can cancel off the minus sign. You can cancel off the minus sign. That's question 2. Okay, that's question 2. Okay, don't worry, don't copy it, don't copy it. Understand first. Understand first. Once you understand, I'll show you the solution. Nice one. Today, I will put it on the G-Classroom as well. Okay, can this is the second one. Yeah. Okay. Yes. Yeah. Okay, some still copying, so I pause a while. Yep. What happens? What do you mean? Or any value of n will work. Any value of n will work. Yes. Yes, you get a button. N is as long as the n is more than how come I stop? Because G prime x is a polynomial. Okay. No one's looking at it, let's see. Okay, so now go to question 3. Okay, question 3. You got part 1 already. Or you got both, but you don't know why. why do we need to start? Okay, so because here, the idea is that they want us to do a differentiation. Okay, it's a polynomial of y. So which means that I'm probably doing this, right? Okay, now then, when I'm doing this, okay, G prime by right is a polynomial of y. So G prime here, Gx equals to f prime. So that means G is equals to this, right? Am I right? Okay, G prime means that I'm differentiating this entire thing. Am I right? Correct? So then I realized that, so this was at this part, and she realized that, hey, now I want to differentiate y. Unless I'm taken GH form in, I learn implicit differentiation. If not, I will have to change it to tangent x. Okay, so that's where you realize, hey, is it maybe Yesu want to try something like that. Tangent n minus 1x plus n tangent n plus 1x. Is that okay for you? Can when you differentiate a function with respect to y, right, you will need implicit differentiation. Have you heard of this before? You take in? No, then you might so that's why I will not be able to proceed, right? Then because if I want to differentiate y, I can't. You know what I mean? So that's why I change it back to x. Can I? You can't differentiate. What do you mean again? Sorry. You don't have the tools to. You haven't learned how to differentiate yet. So again, you haven't learned how to differentiate yet. So if you want to differentiate something, right? Okay, if it's in terms of x, can do, right? So that's why we'll try to change it to terms of x. But if it's in terms of y, we can't yet. Not that you cannot. It's just you will learn it. Everybody will learn it in senior high 1. So who takes aim? Those who take aim, you have learned implicit differentiation. So this one is implicit differentiation. Okay, so it's a little tough. So to me, the question is a little tough. Okay, sorry. I don't know. So here, okay, so then you see n is equals to 5. N is equals to 5. So yes, so n equals to 5, right? So this is the same as differentiating 5 tangent power 4x plus differentiating 5 tangent power 6x. Then that's where you use the earlier result. This one. If you differentiate something like this, right, you do this, right? So this is a legit case where you see if I'm differentiating y power n, that means this n is like this 4. Okay. So in this case, you apply the result. The result is that differentiating tangent n power x is supposed to give you n of tangent n minus 1 x plus tangent to the power of n plus 1 x. Or you can also say differentiating y power n is n y power n minus 1 plus y power n plus 1, where y is equals to tangent x. Is that okay? So I go to the question, right? This case, you substitute n to be 4. You substitute n to be 4. You substitute n to be 4. Here, you substitute n to be 6. Can I? Okay, so after which, I write down my formula. What will this give me? This will give me 5. The left-hand side will give me, let's call this like y power 4. Let's call this like y power 6. Okay? So this is supposed to give me 5 of y cubed, 5 times 4 of y cubed plus y power 5. 6 of y power 5 plus y power 7. Is it okay for this part? This part to this part. Oh, right. It's very good. Then now you look for common factor to remove. I look for common. If you're not comfortable, I can expand everybody first. So 5 times 4 is 20. 20y cubed plus 20y power 5 plus 30y power 5 plus 30 again, 30y power 7. You factorize out y power 3. Okay? And factorize out 10. Oh, and what are you left with inside? 1 plus 2y power 2 plus 3y power 2 plus 3y power 4. Okay? Okay, this is again factorizable. Okay, this is like 3y power 4 plus 5y squared plus 1. Then y cubed. Okay? What will this give me? This will give me 10y cubed. 1 plus, I think you can split it this way. 3y squared and y squared. 1. See 1 and 1? Wait, let me think. Oh, 2. This is 2, sorry. So this is 1, this is 2. Yeah, that's the answer. Okay? So back to your question. Yeah, this is a part where basically the teacher who said this question, he took a JC1 question and brought it down. That's why it looks a little out of place. Yes. How do I do it in tangent form? It's a little tougher. Because when you differentiate tangent, chain rule will get you secant square. Which is you need to manage secant square and tangent square plus 1. Which you have already have done it in part 1. Oh, okay. Okay, so let me just go through the question again. For recording purposes as well. Okay. Okay, now, did everyone get this step? Joshua can get? Can get. Anyone cannot get this one? Yes. Okay, change back to tangent. Okay, so 1 second. Let me go through. Okay. Maybe I go through. Okay, so now if I look at this, right? Gx equals to f prime. What is f prime? F prime by right is equal to n y n minus 1 plus y n plus 1. So there are times where you are jumping to tangent x, there are times where you are not. Okay? So after that, from here, how do I express y and g prime? So actually, you need to g prime. G prime means you need to differentiate again, right? It means that I'm differentiating this, or can I say it's like differentiating f prime again. Okay, later on in topic 6, you will know that f prime, we differentiate f prime a second time, usually what we write it? We write it as if f prime I differentiate one more time, call it f prime prime. Very good. How can I do it? Okay, so double prime. Okay, so here it means that I'm differentiating this, right? Draw the top. Okay, so this is differentiating. How do I differentiate? How do I differentiate y? Yeah, so if you know implicit, now of course you have a slight disadvantage. Yes. So what I'll do is already this way. Then already as n tangent n minus 1x plus n tangent n plus 1x. Because from here you know that Because from here, you know that y is actually equal to tangent x. Okay? And I won't come out so hard. It just will stretch. You know, this AFL assignment questions are always hard. Why? Stretch your not most things. But please not all values. Okay. Okay. So of course from here, then how do I differentiate this, guys? So this is just a temporary appearance. How do I differentiate this? How do I differentiate this? So now you see you let n to be 5. Let n to yes. Yeah, let n to be 5. Let n equals to 5. Which means that you are differentiating what? 5 y power 4 plus 5 y power 6. Correct? And from the part 1 tells you what? Part 1 tells you this. Yeah, part 1, you must experiment on the part 1 tells you that when you differentiate y power n, gives you n y n minus 1 plus y n plus 1. Okay, I'm going to copy this again. Differentiate y power n equals to n y power n minus 1 plus y power n plus 1. Okay, I will copy this again. This is what you learn in part 1. You must remember. Okay, yeah, it's just that we have a lot of points at home, but we don't really play around there. This is a good point. That means why? Edison. If n equals to 4, what is this? 4. What is this? 4. What is this? You say louder, I cannot hear you. Answer so big, voice so small. Okay, say louder. Louder. 3. This one? 5. Okay. Next person, listen to another person. Megan. Okay. Megan, n equals to 6. This number will be n is 6. This will be 6. This will be 7. 6, 7. Okay, this will be 5. Okay, this will be 6. Can you see? With a twist of the numbers and a new friend found. Megan, try to understand? To understand. You need to follow. You need to follow. You go and do other things, you come back, then you say, I don't understand. It's not fair. Yeah. So you must pay attention. So actually you don't talk to your friend. Talk to your friend, you come back, you don't understand. Yeah. So I again remind you that Mitra is part 1 formula. Part 1 formula. I start n as 4. I start n as 5 and 6. Okay. So what does this mean? See carefully, See carefully, This one, what does this tell you? This tells you this, right? What is this equals to? It is 5 or. So this how I'm looking on the right side of the board. So this how what is 5 differentiate y power 6. See how I'm looking at the right side of the board? Okay, now. Okay. Yes, or maybe after my time's up already, man. Why you look at the clock? Whoever look at clock is a tortoise. Okay. Stupid Edison, don't look at clock. Okay, so yeah, then you see after that you factorize, then you get this answer. Okay? Yeah. So I'm trying to sell you. Look at both answers. This is question 3 part 2. 3 part 2. Question 3 part 2. Anyone don't understand? It's big. So you see the tangent is just a brief appearance. Or just a brief appearance. If you don't want to let tangent appear, it's okay. It's you can okay. But just that why if I talk about formulas for myself, right? You have not learned how to differentiate y. But if you're talking about using the information from the question, yes, you can. The question gave you a specific way to differentiate y. But when you go to senior high, also we senior high will give you questions like this. For example, differentiate secant 1. But differentiate ln y. Differentiate a power y. This is senior high. What's the difference between y and x? X and y, one is an independent variable, one is an independent variable. Right now, that's a very simple equation, right? The first time you put together in y and x is they are two number lines for the axis. Okay? Yeah, but when we differentiate with respect to one variable at one time. You do physics, right? You do physics, right? How many variables do you work with in physics? Let's say you do like you work with height, you work with volume, you work with height. They are all different variables, right? Right? So let's say for example, my height is a function of height. For example, 3t squared plus 7t. Maybe Zoe has a cylinder. The height of her cylinder, you spotted it as time goes by. Time is 1 second outflow. So you can see there are two variables. One is height, one is height. Other variables is radius, volume, mass, right? But here, height is in terms of time. Right now. Can I still do D? Can. Can I do dV? So can. So that this is just another variable. Oh. Yeah. Which one? Check calculation instead. Check yourself. How to find? Huh? Then you did secant square. Okay, then you will have a slightly harder time. You will have a slightly harder time. It might be tough. Yeah, my suggestion is no need. Try again without secant square. You can still change secant square back to tangent. Change it. Then you use about 5 pages. Is your pen in enough? I mean, use about 5 pages of try to do an easier way. Do an easier way. You can do that. You can still get the answer. My suggestion is try a shorter way. You can't. Yeah. So learn to let go. So hang on to your X. Yeah. So actually secant square very tough. Do you want me to go through again? Ariel don't need to pay attention. Alanis, no, don't need to pay attention. Zoe. Because you are differentiating with respect to x, not y. You understand? Okay. Okay. Y equals to pi to the power of 6. Zoe, what is dy dx? Yeah, there's no x. Understand? You cannot because you don't know what is y. Y need to be a function of x. But if we use the formula question, it can do. Okay. So here to here, if you do this, right? If you differentiate y power 4, question will tell you differentiate y power 4 is 4y3 plus y5. Question will tell you differentiate y power 6 is 6y power 5 plus y7. This is from the question part 1. Okay, from here. From here. Yes. No. I can't tell you because we haven't set. Yeah. We haven't set. There's a chance for everything. Go in. It's fine. Yeah, there's a chance for everything. My take is won't. My won't. Okay, so why? Because I understand the reference. EFL assignment, you always see very hard. Those things stretch your thinking. But YEA assessment is all. You can handle, right? Yeah. This one can handle. Yeah. I think I do. Let me check. Yeah. Is it okay? Should I stay here or should I go on? Stay. I stay. Okay, okay. I pause a while. Okay, I'm going to start. Now stay focused, stay focused. Okay, so I believe the last time round we have done part 1, right? Am I right? This is the faster class, right? Have I done part 1 with you? Yeah. No, I cannot do it. Okay. Okay. So part 2, we are starting on part 2 today. So you start ready? Yeah. Okay, ready? Ready. Start. What are you doing? Pay attention. I'm helping her. Okay. Okay. So the second part, remember, we are going to differentiate exponential function. So exponential function, if you look at e power x, the derivative of e power x is just e power x. Okay, because if you look at the graph, right? Yeah, I mean, it's quite natural when you see e power x. Right? Look at how fast this graph is climbing. Looking at how fast this graph is climbing, right? What do you expect about the gradient? Will it be also climbing up? It will also be climbing up fast. That's why the derivative of e power x is also e power x. Okay, but if you look at e power fx, okay, think of chain rule. Think of no, there's still a gradient, but the gradient is steep. The gradient is the function itself. So e power x, right, is the only function where you differentiate ex, you also get ex. Okay? Okay? The derivative of ex is just so it's just a memorizing thing. Okay. But if I differentiate e power fx, then what I require you, let's say for example, if I differentiate e power fx, then can you all see outer layer, inner layer? Outer layer is this. Outer layer. Where's the inner layer? Inner layer is this. Oh, so when you differentiate outer layer is e power fx. Differentiate inner layer, you get f prime. That's why you notice at the bottom where you differentiate e power fx, dy dx is f prime dfx. It's basically chain rule. Okay, differentiating a power x will give you a power x log a. Okay, later on you will get to prove this. I'll show you why later on. But similarly, if you have a power fx, listen. You must listen. It's not your aunt. Yes. Okay, so the proof actually can be used by first principle. But if you see e power x, right, you just observe. The idea is that the gradient function of an exponential graph is actually also exponential. Can you see it's the same? Yeah, it's the same. Can you see it's the same? They're the same graph. So the idea is that because when you draw a tangent, sorry, my screen hang, the gradient is so steep that the gradient of the exponential function is itself. So differentiate yes, it's just yes, because of the nature of the graph. It's going very fast. Okay, when it's climbing so fast, the gradient of the exponential graph is also exponential. Okay, but if it's a power fx, okay, if it's a power x, it will give you a power x log a. Okay, maybe you all try to prove this first under 2.1. Okay. So let's say if you are confused, try something like this. Okay, you know that write a as e to the power of, I'm going to end lesson of the boiler. Okay, e to the power log a. Then what is a power x? It's the same as e to the power of log a power x. Okay, Okay, go. Pass on. 1 minute up there. Okay. Which is the same as e to the power of x log a. Okay. Then try differentiating this. So what do you get when you differentiate this? After math quiz, everyone brain cells like gone by half. Or that's all I did. What does that give you? So you see, this is the same as differentiating e power log a times e power x mark, right? Okay, all. Once again, sorry, 1 second. Wrong. Okay. So you can think of this like fx. Okay, think of this like fx. Power x. Okay. Times e power log a. Power log a is the same as e. Oh, wrong. Okay, wrong. What does this give you? If you treat this like fx, right? It's a multiple of x squared. Now, what is ln a? You differentiate ln a times x. What does that give you? If you differentiate x ln a, what does that give you? Ln a. Okay, so you have ln a multiplied by e to the power of x ln a. Okay, because this is f prime, this is fx. Okay, here to here, remember when we differentiate e power fx, it's the same as f prime e power fx. Okay, and what is e to the power of x ln a? Basically just a power x. Ln a power x. Okay. Question 2.1. I want to. Why all last time you want to go toilet? I already go to end lesson already. Don't okay. I already start here. Okay. This class, the boys are happy very bad. You let.
It's like you get the x plus x minus 1.
One more time. Sure. Listen, stop a while, listen. Guys, listen up, so I don't need to keep repeating. If not, I repeat, then you didn't understand. Joshua, are you listening? Yes. Okay, can you wait? Okay. So, here, first of all, differentiate e power x is e power x. There's no proof for this. The proof is by first. Actually, all the proof for differentiation is by first principle, which I didn't go through. I skip. Okay, of course, it's to me it's not very useful for you at this stage. Yeah, but at the end of the day, some of the formulas you can still use. You don't need to know them, but you need to know how to use. Okay. Now, is this okay? Now, if this is okay, A, some of you still don't know what. I will go through during the lesson. A is the same as e power log A. Can I? So if you do not know why, just yeah, I let y goes to e power log x. I log both sides. Do you see if I log y is the same as log e power log x? And then what am I doing? What this is log e, right? This is log e to the power of log x. And what happened to the log x? I bring down. So this is log x multiplied by log. What is log e? What is log e? 1. So you can see log y equals to log x. Log y is equals to x. So what am I trying to tell you? This is just, if y is equals to x, this is just equals to x. X equals to e power log x. A is e power log a. So that's for, are you listening? And A is e power log a. Clear so far? Can I think repeated this like 7, 8 times this whole 2 years already. And you also don't know. It's very, very crucial. Very, very crucial. Okay, in certain situations. This example, you don't know how to do, don't worry. It's not coming out for exam. They don't test you how to do, they test you how to use. You understand? Can I? Yeah. Can I? So after that, I look at this part. I look at this part. Let me go through this part. Let's go from here. Okay, understand? Still my time here. My time. 4 minutes. Here. Okay. So differentiate e power x log a. Okay. So look carefully. Yeah. Don't need to go through this once. If you never pay attention, don't ask me to repeat. It's not fair. Okay. This e power fx is by right? F prime e power fx. Correct? So I ask you, if this is my fx, what is f prime? If I differentiate 7x, the answer is 8x. Answer is 10x. Answer is log ax. Answer is log a. This is log a. You understand? Okay? Because this is a multiple of x. That's just copy paste. Power x. Or Okay. What's e power x 1a? We all know that's how it's just a power x. That's why it's just a power x times 1a. Okay? Can you don't need to prove. You need to know how to use. Okay? I don't need to know how Jaden Lloyd get his muscles. I just need him to help me carry weights. You understand? Later, Jaden Lloyd, help me carry some boxes later. Okay? Okay, you understand what it means? So you need to know how to use, not how to prove. Okay, huh? Can I? Okay. Next, so this week, do your top module, topic 4 assignment. Jaden Lloyd. Jaden Lloyd, are you listening? Stop looking at your watch. Okay. You need to do your topic 4 assignment, practice sets this week. Because this week I will go through. If you do not know when to go through, you look at the Google Sheet. Everything is nice. Okay? Okay, that's all. Thank you, class. Okay, thank you, class.